Chapter 21, Set A, Exercise 8, wants to emphasize that when you take different samples, you're going to get different estimates. So in this case, we have 3 different people that each took a sample of 400 from the same population. And from the same population, person 1 got 72 out of 400 that were ones. We're counting the ones. Person 2 got 84 out of 400, and person 3 got 98 out of 400. What we want to do is we want to find an estimate for the percentage for each one of these people and a give or take for each one of these people. Okay, and so for our estimate, how do you find the estimate? That will just be your sample percentage. So for person 1, let's write that, I forgot, so I'm doing person 1. Your estimate will be your sample percentage, so that will be 72 out of 400, and to make it a percentage, you have to times by 100%. So 72 divided by 400 gives me 18%. Now for your give or take, that means find the expected value. Well, which expected value? We're dealing with percentages, so use the formula for percentages. Now that formula says population percentages in it, but we can't use the population percentage because I don't know what it is. So we'll estimate, I'll do those squiggles, I'm estimating, and do my sample percentage. So we'll do our sample percentage times 100 minus the sample percentage divided by the sample size. Okay, so let's see, this should be the square root of, should be 18 times 100 minus 18 divided by 400. Make sure you use a lot of parentheses when you put it in your calculator. And I get 1.92%. So person 1 is going to have an estimate of 18%, give or take 1.92%. So that was person 1. Person 2, their sample percentage is going to be equal to 84 out of 400. And we'll have to times by 100%, which gives me 400, not 410. 21%. So notice they're off a bit, and that's okay because we know that every sample will always be off a little bit different from the other samples. And so my expected value for my give or take will be the square root. We'll do 21 times 100 minus 21, all divided by 400. Which gives me 2.04%. So that means person 2 has an estimate of 21%, give or take 2.04%. And if you try person 3, they're going to also get something that is slightly different. And that's really what this problem wants to emphasize, is each different sample will get slightly different results. That's okay, it's just part of statistics. That's part of why we put on a give or take, because we realize that we're probably going to be slightly off anyways, just based on which sample we picked and all of that just natural error of how we change from sample to sample.